So in the previous videos, I talked about this kind of problems, and now I'm going to show you how to solve this kind of problems. Remember, when we apply the limit laws, we will end up with 0 over 0, which is undefined. So what is the strategy that we're going to use in order to solve this kind of problems? So let's see. Calculating a limit when f of x over g of x has the indeterminate form, which is 0 over 0. So the first step, we need to make sure that our function has the appropriate form and cannot be evaluated immediately using the limit laws. We will try the limit laws that we practiced in the previous video, and then if we come up with the indeterminate form, then we will follow the next step. The next step, we need to find a function that is equal to h of x, which is equal to f of x over g of x for all x, where x is not equal to a, over some interval containing a. To do this, we may need to try one or more of the following steps. So this sounds hard, but it is not really. The first thing that we can try is if f of x and g of x are polynomials, we should factor each polynomials and cancel common factors. And I will give you examples later on. The second thing that we can try is if the numerator or denominator contains a difference involving a square root, we should try multiplying the numerator and the denominator by the conjugate of the expression involving the square root. And I will show you an example as well. The last step that we can try is if f of x over g of x is a complex function, we begin by simplifying it. Last, we apply the limit laws that we know, and we will then be able to solve the limit. So let's try. Let's evaluate this limit. We have the limit of x squared minus 3x over 2x squared minus 5x minus 3 when x approaches 3. So first, let's see if it's going to give us the indeterminate form. If you apply the limit laws, you will see that if you plug 3 here right away, you're going to get 9 minus 9, which is 0, over 2 times 9, 18 minus 15 minus 3, which is equal to 0 as well. So this is definitely going to give us the indeterminate form. Since we have a polynomial here, we have a polynomial here. So the first step that comes to mind is to factor the numerator and denominator and try to remove common factors. Let's see if we can do that. So this will be equal to the limit of, I'm going to pull x out as a common factor. You will end up with x minus 3 over, when x approaches 3, over, and then I'm going to factor that. So this is basically 2x, and then I will have x in here. This is x minus 3. So we will have 1, positive 1. Let's try positive 1. Now let me just make sure. So we have plus 1x minus 6x, which is negative 5. So that is the right way to factor. I posted some videos as a review for the ways to factor polynomials and factor specifically quadratics. So make sure to watch those videos to refresh your information about the factoring. Notice how I have x minus 3 here and x minus 3 here. That is a common factor, so I'm going to cancel those together. This is a new function, h of x, which basically resulted from factoring the numerator, factoring the denominator, and canceling common factors. So we will end up with the limit of x over 2x plus 1, where x approaches 3. Now, since I'm familiar with the limit laws, I know that it's going to be the limit of the numerator over the limit of the denominator, but I can save myself some time and do it right away. So this will be, I'm going to plug the 3 in here, the 3 in here. I will have 3 over 6 plus 1, which is 3 over 7, and that is the limit in this case. Now, let's evaluate the limit of x squared plus 4x plus 3 over x squared minus 9 and see if we can do that using the new strategy. So as you see here, if I plug negative 3 here right away or use the limit laws, which is the extended version of it, I'm going to get the indeterminate form, which is 0 over 0. I don't want that. So I am going to use the strategy again. First, I'm going to factor the numerator, factor the denominator, and try to eliminate common factors. So you will have limit as x approaches negative 3 of the factoring of the numerator over the factoring of the denominator. I'm going to start with the denominator x squared minus 9 is basically x plus 3 and x minus 3. And x squared plus 4x plus 3 is basically x here and x here. I'm looking for two numbers. Their product is positive 3. Their sum is 4, which are positive 1 and positive 3. Notice how I have this common factor. It's x plus 3 here in the numerator, and it's in the denominator, so I can cancel these together. This will give me the limit of x plus 1 over x minus 3, where x approaches negative 3, which is equal to, applying the limit laws, this is basically negative 3 plus 1 over negative 3 minus 3, which is negative 2 over negative 6. If you simplify this, you're going to get 1/3. And that is the final answer. So the limit in this case is equal to 1/3.